revision class series. As we already discussed from the start series, we have completed Fourier series, Fourier transform, discrete time. In Fourier transform, we have been completed continuous time Fourier transform under discrete time Fourier transform. Then we have also discussed about Z transform. Then we have been discussed about sampling theorem. Then we have discussed about Laplace transform. So all the important things has been concluded along with its properties. Everything I have been detailedly explained. In this session, we are going to start from the basics of signals and the system. That is the final chapter. I will cover all important properties of each and every signal. But before that, in the last class, I told you that we left one small portion in Laplace transform, that is region of convergence. See, the region of convergence in Laplace transform, it's similar, same thing as we have discussed in Z transform also, but still there is a slight minute variation will be there. Let us see how it is varying from the basics, from Z transform. What we are doing, it is the revision class. Hope you all already studied these things. I will just give a small intro. Whenever we are discussing about Laplace transformation, first thing, while talking about region of convergence, we are always drawing vertical lines in order to conclude whether this system is a causal system or it is a non-causal system or it is anti-causal one. At the same time, whether the given system will be stable or not, whether it is including j omega axis or not, whether it is having the properties of causal. I have covered something in the last class itself. Still, what is the meaning of region of convergence? Just to recollect once. In Z transform, we are defining it in terms of circles. But here, we are defining it in terms of vertical strip lines. What you have to do is, first take any some random signal, whatever that will be given to you. Whenever you are trying to draw its correspondent region of convergence, ultimately the first step you have to do is draw the correspondent vertical strip. For an example, let us assume that the given signal is having a pole of 1 upon s plus 2. And it's given that its region of convergence is greater than minus 2 mod z. It's ROC. Region of convergence is going to be, its region of convergence is going to be greater than minus 2. How it is greater than minus 2, sir? If the signal is causal or right-sided signal, assume it is the right-sided signal, or it will be defined like this: e power minus at into u of t. If a signal will be defined like this, then we know its correspondent pole in Laplace domain can be written as 1 upon s plus 2, and its correspondent region of convergence can also be written as real part of s must be greater than minus 2, as it is given. It is already s plus 2 means s equal to minus 2. Now first locate the pole in its correspondent location. We know region of convergence does not include any poles inside its region. You should not keep any poles. First draw a vertical strip exactly on the location of the pole. From this location, first cross check whether your signal is a right-sided signal or left-sided signals. Since we are taking the given signal is a right-sided one, if the signal is a right-sided signal, then you will have to draw the region of convergence. From that pole, you should draw your region of convergence. So from the location of the pole, you have to consider the entire region from minus 2 to plus infinity. The total region will be considered as region of convergence, ROC. While developing region of convergence, I have also told you that if your region of convergence includes j omega axis, imaginary axis, then such a system will be treated as a stable system. If your region of convergence does not include the region of convergence, j omega axis, then such a system is considered as unstable system. That's it. Now, if the same signal will be given at the opposite side, like if I am taking e power minus at only, but in the opposite direction, u of minus t, then that signal will be treated as a left-sided signal. Then this given signal will be treated as a left-sided signal. Then in that case, the real part of s or region of convergence is going to be less than -2. Then what you will have to do, sir? For this, if you are drawing region of convergence, it is going to be from -2 onwards, you are supposed to draw the region of convergence towards the left hand side. First, locate the pole in its corresponding location as it is given, that is -2. After that, draw a vertical strip here. So you have to draw a vertical strip. Then if it is left hand side signal, then you have to consider its correspondent region of convergence is going to be -infinity to -2. That is how we are developing ROC, region of convergence. Sometimes common ROC will be given. Like suppose if your question will be given like this. Let us assume a signal will be defined as 2 into e power minus 2t into u of t minus 4 into e power minus 3t into u of minus t, if it is given like that. If a signal will be given like this, then how will you draw the ROC, sir? Let's see. For the first signal, you will have to define that region of convergence is going to be, since its correspondent Laplace can be written as 1 upon s plus 2. It means the ROC is going to be -2. Whether it is greater than -2 or less than -2, it should be greater than -2 because it is right-sided, causal signal. Whereas the second one is anti-causal because it will be traveling in the left-hand side, u of minus t. Its correspondent Laplace I can say for e power minus 3t, it can be written as 1 by s plus 3. Then ROC is going to be less than -3. Why it is less than -3, sir? Why it is less than -3? Because see, s plus 3 means s equal to -3. Real part of s will become -3. Then whether it is less than -3 or greater than -3, that will be decided by the given sequence. You can observe whether it is multiplied by u of t or it is multiplied by u of minus t. If it is multiplied by u of t, then the signal will be a right-sided signal or a causal signal. If it is multiplied by u of minus t, then that signal will be a left-sided signal, or we can consider it as anti-causal signal. If both people are lying together, then that signal will be treated as what you will say, sir? That is common, causal, non-causal signal. If it is having common ROC, like two signals are given, one is traveling in left side, another one is traveling right side, then cross check the common area between them. Based on that, you can predict the resultant nature. Let's see if you are drawing the ROC for the given one. We have two poles. One is s plus 2 means at s equal to -2 we have a pole. Sorry. And at s equal to -3 also we have another pole. Now cross examine how to draw the ROC for both of these people. From the given data, if we are developing the ROC, first wherever we have the pole, first draw a vertical strip before concluding it. First draw a vertical strip. Then mark the pole values. The value of the first pole is -2 and the second pole value is -3. After that, cross check whether it is right-sided sequence or left-sided sequence. If you are cross-examining, first one what we found is ROC must be greater than -2. Greater than -2 means this is right-sided sequence. It will be running like this. Yes. And the second one, if you observe, region of convergence will be less than -3. It means it should be like this. You will have to draw. Now, whenever we are having more than one signal, it is very important to cross-examine whether the resultant signals are having common ROC or not. Whether let us say the region of convergence is A, common ROC. This is region of convergence is B. Do they have any common intersection between them? Whenever we are having more than one signal in a given sequence, you will have to identify the common region of convergence. If there will be no any common intersection between A and B, then since there is no common intersection, see that A is here, B is here, they are not touching each other, sir, then Laplace itself does not exist for the given function. Laplace does not exist. That's it. This is how you have to give your answer. Suppose the second thing is, if we are taking, let me go ahead with the same signal, but I'm just going to flip it. What I'm going to do now, let's take the same example, but rather let us assume e power minus 2t it is given u of minus t minus, okay, let us take whatever it is, e power minus 3t into u of t. If a signal will be different like that, then how will you define the region of convergence? Only focus on ROC. I am not focusing on Laplace at all. We know for this the correspondent Laplace transformation will become 1 by s plus 2. Then for this its correspondent Laplace transformation will become 1 by s plus 3. Then what I can say? Directly you can define. Sir, even you no need to do these things at all. I will tell you one thing. Listen, while developing our region of convergence, even no need to do all these things. Only focus on the given. What it is given here? It is given minus 2. Okay, then first write down region of convergence will be minus 2. For the second one, what it is given? Minus 3. Okay, write down region of convergence will be minus 3. The next question, whether it is less than or greater than, that you will have to predict from the given data, given signal. What it is given? First one is u of minus t. U of minus t is an anti-causal signal. It will be lies only on left hand side. Left hand side means less than. Finish. Cross check the second one. U of t. It is a causal signal. Causality. I should travel in right hand side. So its correspondent should be greater than minus 3. After doing this two, now cross examine. Develop the ROC for the given. Now we are going to develop the ROC. Look at the pole first. At s equal to minus 2, minus 3, we have 2 poles. After that, draw a vertical strip. The immediate step is drawing vertical strip. Yes, I have drawn the vertical strip. Here also, I am drawing the vertical strip. After drawing the vertical strip, now let us develop the region of convergence, ROC. How will you develop the region of convergence, sir? The first one, here we have minus 2. 1 second. Yes. See, here we have minus 2. Here we have minus 3. Now, cross check. First one, region of convergence for the first signal. It should be less than minus 2. The ROC is going to be less than minus 2. It means we are going to develop the region of convergence for this given sequence from minus 2 to minus infinity. This is the complete ROC. Yes. Now, let us focus on the second one. The second one is what, sir? The second one is region of convergence should be greater than minus 3. Greater than means towards right hand side. From minus 3 to infinity, you will have to draw the ROC. After that, whenever we are having more than two signals, it is very important to observe the common ROC. Let me consider this is region of convergence A and this one is region of convergence B. Now identify the common intersection zone between them, A intersection B. Where they have common sources, see there, between minus 2 to minus 3, if you observe, both the ROCs are intersecting each other. Yes. So the common ROC will going to be, that is the resultant region of convergence. The resultant region of convergence strictly lies between minus 2 to minus 3. Understand, sir? This is how we are developing ROC. So whenever it is given, it is very easy just to focus on what is there in the power. It is minus 2. Okay, write down. Region of convergence will be minus 2, minus 3. Whether it is greater than or less than after that. You can just cross check. So immediately draw the strip and observe. Is there any common ROC or not? If it is there, then okay. If it is not there, then write your answer that Laplace transformation does not exist for the given. That is how we are developing region of convergence whenever we are in Laplace domain. Hope you all understand. Now, sometimes what will happen is while developing region of convergence, they will give this type of signal. Wait, I will give one more example. Let us assume a given function x of t equal to e power minus 3t into u of t plus I have one more function e power minus 2t into u of t. Now, how should I draw the ROC for this? If you are having more than one right-sided signal, I will tell you. For the first one, first write down region of convergence minus 3. Second one, write down region of convergence minus 2. What is your next step? Identification, whether it is greater than or less than. How will you do that? See there, the first one is right-sided signal greater than minus 3. Second one, it is greater than minus 2. In this case, what will be the region of convergence, resultant region of convergence? Now from this, what you have to choose now? Both are right-sided, both are right-sided. Then choose From the right hand side, you will have to choose the right of rightmost pole. Right of rightmost pole. You will have to choose right of rightmost pole will be your answer. Will be your ROC. It means what? If you are locating the poles in its corresponding location, one will be located at a -2, another one will be located at a -3. Now what you have to do is start your journey from here, reach the right of rightmost pole. Which pole will be located at last? That is the last pole on the right hand side. You have to reach the right side, rightmost pole. Final one. That will be your resultant ROC. Greater than -2. Finish. Now suppose there are 5 poles will be given, and those 5 poles has been located like this. Let us assume I have a pole at -4, and I have one more pole at -3. I have one more pole at +1. I have one more pole at +2. All these poles are right sided. For all of them, ROC will be right sided, right side, right sided. Then what will be the final resultant ROC? The resultant ROC will be right of rightmost pole. So the resultant ROC will become greater than 2. Finish. So whenever we are having more than one right-sided signal, you will have to choose the right of rightmost one will going to be your resultant ROC. Similarly, for left-sided sequence, if it is given that e power -3t into u of -t, and it is given that e power -4t into u of -t. Now what should we do, sir? For the first one, what will you say? First write down region of convergence. For the second one, write down region of convergence. First one, it is going to be -3. Second one is going to be -4. Whether it is less than or greater than, that is the question mark. If you observe, the first one is anticausal. Of course, the second one also anticausal. So this is u of -t. The second one also anticausal. If both are anticausal, then put less than. If you have more than one left-sided signal, then you have to choose left of leftmost pole. It means I'm having -3 here, I'm having -4 here. Both are left-sided sequence. Then the ROC will going to be, you should travel from right to left side. If the signals are left-sided signal, then you should travel from right side to left side. If the signals are right-sided signal, then you have to travel from left side to right side. Then reach the right of rightmost pole in case of right-sided signal. Reach the left of leftmost pole in case of left-sided signal. Then find the final pole on the left-hand side. That will be your resultant ROC. So region of convergence should be less than -4, not greater than. It should be less than -4. You should travel from there. From here, all the region will be treated as region of convergence. Hope you all understand. This is how we are identifying the region of convergence whenever a Laplace sequence will be given to you. Fine, sir. Now we are entering into the final part, that is the basics of signals and system. So let me cover all other important things. Let us consider basics of signals and a system. As we are observing, we are having so many classifications on signals, and of course we are also having so many classifications on systems. So let's start from the beginning. We are having two types of signals. One is called continuous domain signal and another one is called discrete domain signal. How do we represent all these things? If you are in continuous domain, then it will be represented by T. If you are in discrete domain, it will be represented by N. If you are converting any signal from continuous domain to discrete domain, then you will have to replace T by N times of sampling time period Ts. This is the process of converting a signal from continuous time domain to discrete time domain. That you must remember. This is a little bit important. A direct one more question will be asked. For an example, let us assume I have a signal x of t. It is given that cos of 2t. Now, what we want is its correspondent sampling interval will be given. Let us assume the sampling interval has been given as 10 seconds. Now, the question is write down, identify its equivalent discrete domain signal value x of n. Now, in order to call this name, see, in continuous domain we are calling it as x of t. In discrete domain, this continuous sequence of the signal will be simply considered as x of n will be equal to, but in its correspondent value, what you will have to do is, wherever you have t, replace it by n times of ts. I told you the process of converting a signal from x of t domain to x of n domain. X of t will be treated as x of n. Inside the signal, whatever the properties of the signal that will be given, inside the signal replace t by n times of ts. Then this will become cos of 20 times of n into ts will be replaced by, it is given in the question, 10 seconds. So this will be rewritten as cos of 20 into n. This is discrete domain. This is how we are transforming a signal from continuous domain to discrete domain. A little bit important process. Direct questions will be asked in the examination from this year. Fine. Let's continue, sir. Next. So the first most important standard signal, let us discuss, that is impulse signal. Now if you are observing the value of impulse signal, what will be the magnitude of the impulse signal? First representation of the impulse signal is del of t. And this impulse signal value is, it is having certain value. This value will be, wait, I am writing first a magnitude. This magnitude will be 0 if the value of t is not equal to 0. And this magnitude will be approaching to infinity if the value of t is exactly equal to 0. What most of you are thinking, after observing this property, if they are asking in the examination, if they are giving, identify the magnitude of del of t minus 1. Immediately you people are writing that your answer is going to be, you are applying the same property. It will be 0 for t is not equal to 0 and it will be infinity when the value of t will become equal to 0. Is it correct, sir? Identify the location of the signal first. Where your signal is located, the actual location of the signal. First signal has been located at t equal to 0. That's why at t equal to 0, its magnitude is approaching to infinity. Whereas you are observing, if you are observing the second signal, where it is located, sir? This signal has been located at, let me define. At t equal to 1, this signal value will be approaching to infinity. Because t minus 1 means from this you will have to define t equal to 1. In rest of zone, this value will be 0. If t not equal to 1, then you can say this value will be 0. So whenever you are identifying or you are trying to figure out the impulse location, signal location, you will have to first identify its exact location, then you can define its magnitude is going to be infinity and of course its value will be 0 in other location. Next, let us find out the area of this impulse function. Throughout the integral, if you are running from minus infinity to plus infinity, the value of del of t, unit impulse, its corresponding area will be approaching to 1. That is the another most important property of the signal. You should not forget. Sir, it is valid everywhere. Even it is different for 0, or if your signal will be, let us assume for an example, if your signal will be defined from minus 1 to, 1 minus to 1 plus. Just if I am selecting a specific point, 1, left hand side is called 1 minus, right hand side near to that point is called 1 plus. If your limit is running from between these 2 points and it is given that del of t minus 1 into dt is what? If they are integrating, then this value will be approaching to 1 at t equal to 1. Okay, so it is very important to observe it carefully. Sometimes what they will do now, they will be giving the value from minus 2 to plus 2. Whereas internally if you observe, it will be given that del of t minus 3 into dt. What will be its value, sir? Is it 1? No, this value will be 0. Why? Because if you observe the location of the signal, del of t lies at t equal to 3. Whereas they are running from minus 2 to plus 2. So t equal to 3 will not covered under this area. So the resultant answer will be approaching to 0 because the del of t minus 3 does not lies under the given area. So that is another most important property of the impulse signal that you must keep it in your mind. Next, the another one is whether the del of t is an odd signal or even signal. The next most important one is whether the del of t is an odd signal or it is an even signal. Suppose, let us see the first one. I will directly write down the answer. Del of t and del of minus t both are equal to each other. It means impulse signal is an even signal. Impulse signal is an even signal. First one. That is the first important property. And the next important property is, suppose if I am scaling this signal, if I am having a signal del and it has been scaled by a factor of p times of t, then what will be its corresponding equivalent value? Del of pt is equal to 1 by mod of p times of del of t only. So this is another most important property. Of course, often being asked in the examination also. Suppose in place of p, it is given that del of minus pt. Then what should I write? You can write on the same answer. Still it is going to be 1 upon mod of minus p into del of t only. So what will be your answer? Your answer is going to be 1 upon mod p. Mod of minus p, mod of p both are same, no sir? Del of p into del of t. Correct, sir? Because see, you know, del of t is an impulse signal, sir. Del of p to del of minus t should give same answer. See, as we are observing, already I have defined it here. This will not change. So you should remember this property. That is another most important property. Suppose if it is given that del of, let us assume I am having pt plus q. If it is having a shifted version, then what will be the resultant answer of this given? Nothing. Simply take the value of p outside. So it can be written as 1 by mod p and del of t, new location is going to be, if you are taking p outside, it will become t plus q upon p. This will be the resultant representation of the impulse function. That is another most important property. Now, sir, suppose if it is given that del of minus p times of t plus q, then how will you define it? If it is del of minus pt plus q, then it can be defined as, once again, 1 upon, take minus p outside. If you are taking minus p outside, then this function, see, anyway, when the moment you are taking minus p outside, this will become t minus q upon p. That's it. So this can be rewritten as 1 by mod p can be rewritten as 1 upon p. Anyway, it is mod, na sir. There is no point of considering plus or minus sign. Into del of t minus q upon p. That's it. It's over. This is how we are defining impulse function. So it is very important to know its properties properly. If you don't remember these things clearly, definitely it will affect you. So try to understand what I am trying to conclude from here. Now let us see the another most important property of the impulse function. Suppose let us say I am having a function del of t. It has been multiplied with some random signal x of t. What will be its equivalent value, sir? If I have x of t into del of t, this can be rewritten as, sir, it is in multiplication. Dot means it is in normal multiplication. In this case, this function can be written as del of t into x of 0. This is another most important property. See, what is the location of del of t? At t equal to 0, this function will be standing. If you are multiplying this value with any one of the signal, then that signal also will be stand at the same position where your impulse function will be standing. What you are trying to conclude? In the examination, what they will do is, suppose they will be giving like this, e power minus 3t into del of t. What will be its equivalent value? Since it is in multiplication, sir. So this can be written as, see, this is your x of t. First identify the location of del of t here. Del of t is placed at t equal to 0. So this function can be written as del of t will be as usual here, whereas e power minus 3 into t will be replaced by 0. So this will become e power 0. Value of e power 0 will be 1, na, sir. So the resultant answer will become simply del of t only. See how easy it is. But if you are observing this type of question in the examination, that time suddenly you will be stucking. How it is become equal to del of t? How it is possible? Yeah, it's possible. Just identify the location first. Suppose if it is given that, let us assume, e power minus 3t only given. But here what they give is del of t minus 2. What will be its equivalent value? If it is given like this, what you have to do, sir? Take del of t minus 2 as it is. Don't touch that. But here if you observe, e power minus 3, t will be replaced by t minus 2 means t equal to 2. Replace t by 2. If I am replacing t by 2, then e power minus 3 into 2 will become e power minus 6. So this can be rewritten as e power minus 6 into del of t minus 2 will be your final answer. Getting me, sir? So it is very important property, and of course you will have to understand it properly. Nothing else is there, but try to catch it what they are trying to control. Now let us involve into convolution property. So the next most important, that is integral property, we can also call it. See, let us assume same way, instead of in multiplication, still multiplication, but under integral it will be defined. If your function will be given that minus infinity to plus infinity, what they told is they will be defining a certain points. Any value, this minus infinity plus infinity random limit, and it is given that a value will be given as x of t into del of t into dt. If it is under the integral, what we must remember is we studied one important thing. Under the integral from minus infinity to plus infinity, the value of del of t with respect to time period dt will become equal to 1. Correct, no, sir? It will be absolutely equal to 1. So you must observe this property first. Okay, with the help of this, what I can define is, suppose if this signal has been multiplied by, since it is multiplied by x of t, yes. So what I can say is, if it is multiplied by x of t, then only x of t will come out. Because see, integral of del of t into dt will become equal to 1. But x of t will like stands at t equal to 0, because the position of del of t means it will be placed at t equal to 0 only. Suppose in the same interval from minus infinity to plus infinity, it is given that x of t into del of t minus a into dt. This is what it is given. So this can be rewritten as, how will you write down this now? You can take once again x of t, but now this time x of t will stand at the point of t equal to a. So suppose let's continue further. Take some example. It is given that interval from minus infinity to plus infinity, it is given that e power minus 6 times of t into del of t minus 1 into dt. What will be its resultant answer? So you have to cross check once again. If you are running from minus infinity to plus infinity, e power minus 60 into del of t minus 1 dt can be rewritten as e power minus 60 will come out. Yes, and whereas the value of t will become equal to 1. So what will be the equivalent answer, sir? Replace t by 1, your answer will become e power minus 6. That is the final answer. See how simply you are solving. But all you have to do is remembering the properties is very important. So ultimately you should remember how to apply all these things. That is very important. Hope you understand. Now in the same pattern, let us recollect all other signals. Like let us take the step signal. If you are observing the step signal now, how will you do it, sir? When the moment we are focusing on step signal, it will be represented as u of t. First thing, you should represent it in terms of u of t only. Let us consider, if I have a signal u of t, next one, that is called a step signal. So this step signal will be represented as, the representation of this step signal is, this value will be 1, it is running from 0 to infinity. That is called a step signal. Yes. So the value of u of t, whenever u of t will be given, you can define like this. This step signal can be defined as, this value will be approaching to 1 if the value of t will be greater than 0, and this value will be approaching to 0 if it is t, if the value of t is less than 0. This is how we are defining a step signal. If it is u of minus t, suppose instead of giving step, it is given that u of minus t is given. If they are giving u of minus t, if it is given u of minus t, then how will you represent the signal, sir? This will be represented as u of minus t, means this value will be 1, but its corresponding period u of minus t can be defined as, we very well know that it will be defined as 1 when the value of t is less than 0, and it is defined as 0 when the value of t will be greater than 0. This is how we are defining the signal u of minus t. Understand, sir? So this is all about step signal. Now in step signal also we have certain properties. The first most important one is from this step signal only we are defining the another most important signal, that is what we are calling it as signum of t. How will you define, sir? The signum of t can be defined as u of t minus u of minus t. That is how we are defining signum of t signal. This can also be defined as twice of u of t minus 1. So this is minus u of minus t. Okay. Either you can define like this or you can define like this. Both are correct. So function signum of t can be defined in terms of step signal. That is what you have to remember apart from this. And the another most important property, and that is also repeatedly asked in the exam, is if a step signal u of t is given and it is scaled by a factor of u of u of at minus or plus whatever it is, what will happen, sir? Because of the scaling, not shifting. Shifting will change the signal property. Shifting will change the signal property. But if I have u of t and is scaled by a factor of a, what will be the resultant signal? Nothing will happen to your signal. Even your scaling u of at, that will be equal to u of t only. It will not affect your signal property. So what is the conclusion here we can draw is u of at and u of t both are equal to each other only, sir. This is what I would like to conclude here. The next most important property is, other signal is ramp signal. The next one is ramp signal. How to define the ramp signal? Let me define. If you are taking ramp signal, the representation of the ramp signal R of t equal to t into u of t. Simply. And if you are drawing its waveform, how it seems like, sir? With respect to time period, ramp signal R of t will be defined as, it is running like this, see there? It is running like this, that is t, simply t. This is the representation of a ramp signal. We know that very well. Now, next most important thing what we observed is, as we observed, u of a times of t will become simply u of t only. There will be no changes. But when we are observing a ramp signal, this is not the case. If I am having a ramp signal and it is scaled by a factor of a, r of at, then this can be rewritten as a times of t into u of t only. That's it. A times of t into u of t. That is called a ramp signal. So what you have to realize here, there will be a difference. Because in ramp signal, magnitude itself, it has been scaled by a factor of, it is t. Magnitude itself, it is t. If t is scaled by a, then its magnitude also will be scaled by a. So the resultant answer, the slope value will become, line value will become what? A times of t. This is what will happen. And the next most important property is, suppose, okay sir, because of scaling, this is what's happening. If you are shifting, if you are doing shifting also, r of t, a plus b, then what will be our resultant answer? As usual, you will have to take a outside. Anyway, ultimately the value of a will not be ignored. You will have to take a outside. A outside. This can be rewritten as r of t plus, take a outside. Then this will become b by a. This is how we are writing. So r of at plus b is equal to a times of r of t plus b by a. Both these properties are same only. And next thing is, suppose if it is shifted by, if it is flipped, r of minus at plus b, how should I write down this? If it is flipped like this, now remember in ramp signal, one thing what you should remember is, this signal will be equal to, take only a outside, don't take minus. So this will become a times of r of minus t plus b by a. We have taken only a outside. So these two people are equal to each other. That is one of the most important property. Because most of the people are failing to observe these things properly. Okay. So that is all about ramp signal. The next most important one is parabolic. Wait. Let me define parabolic signal. So when we are discussing about parabolic signal, its representation is first of all, P of t is called representation of parabolic signal, and in time domain this will be defined as t square into u of t. Some people will be writing it as t square by t square by 2 into u of t also. Both are correct only. If this 2 will be considered here, then it's in correspondent S domain, we will not be considering it. But in general, whenever we are integrating a ramp function, this is what you are getting standardly. But most of the time, this 2 will be shifted to S domain. So the standard representation is what you can take is its button. You will be going with the t square by 2 into u of t. Take this one, because sometimes when they are talking about standard signal, that time you will be, if you are writing t square into u of t, this may leads to lose your mark. So consider only this one. This is your p of t signal. Fine, sir. Let us moving on to the next one. So this is the representation of a parabolic signal. Okay, that will be fine. Next, what we are going to do is, suppose the parabolic signal representation by t square by t. What is the relation between impulse and all these above signals that we have discussed? If I have impulse, how to obtain step signal? In that journey, what you'll have to do is just pass an integrator. The integration of impulse will give you the value of step signal. Again, if you are passing it through the one more integrator, that will give you the value of ramp signal. Again, if you are passing it through the one more integrator, that will give you the value of parabolic signal. Now the ulta reverse process is, I am having parabolic signal. What should I do? If you are passing the parabolic signal through differentiator, if I am passing it through differentiator, then this will become R of t. Again, if you are passing it through the differentiator, then it will become u of t, step signal. Once again, if you are passing it through the one more differentiator, then this will become impulse signal del of t. Understand, sir? That's it. So this is the relation between these four signals, because these four are standard signal, and you can also observe that we are using these four signals in control system also. It is very rare while testing the signal response, we are not mostly focusing on these two, but still we are analyzing all these signals in control system also. Not parabolic, first three, step signal, ramp, and impulse signal. Okay, parabolic we will just have a small look in steady state error analysis. When we are dealing in control system, if you are passing parabolic signal, then what will happen? That's it. That is the small analysis we will have in control system. Anyway, these are all called standard signal and important signals. The next most important signal that what we are going to look at now is a rectangular function. I will define everything, rectangular and a triangular function. So let us take rectangular first. After that, I will define triangular. See, when the moment we are defining a rectangular function, how should we define, sir? Sir, this is one of the most important property in signals, because based on this rectangular, directly you can observe from Fourier transform, many questions will be framed. From the properties of Fourier transform, from this rectangular only, repeatedly you can observe there are so many questions. So it is very important to knowing its representations in a proper way. How should I define this, sir? First of all, you can define this. Let me draw the waveform first. When we are observing a function, rectangular functions will be represented. It is a uniform even function. It is a perfect even function. This is the representation. It will be represented as, it is running from, let us assume, minus tau by 2 to plus tau by 2. So the width of the signal, the width of the rectangular function will be tau, representation, general representation of a rectangular function, and its magnitude will be a, general value. Sir, how it can be written in theory form? The above function can be written as magnitude is a into rectangular of, in bracket, time period t by width of the signal, where tau represent the width of the signal. What is the total width is tau? That is what will be given here. The tau representing the width of the rectangular function. And you can observe rectangular function x of minus t and x of minus t are both symmetrical to each other. It means you can say rectangular function is an even function. Even function means we can define x of t and x of minus t are equal to each other. In frequency domain, this will be defined as x of omega and x of minus omega are equal to each other, or x of f or x of minus f. You can also define it in terms of f also. X of f and x of minus f are equal to each other. Anyway, ultimately it is an even function. That is what you must remember about the rectangular function. Next, what you can do is further you can continue. Wait. This is the representation of a rectangular function. Okay, that is fine. Now from this rectangular function, what are the things that you have to remember? Whenever your rectangular function will be given, here itself I will discuss one more time. In Fourier transform also I have given this. In rectangular function, it is very important to remember its correspondent Fourier transformation. If you have a function rectangular of t by tau, its correspondent Fourier transform can be written as a tau into sinc of f into tau. That is one way of representing it. The second way of representing a rectangular function is another Fourier transform will be. This is one way. The second way of its representation will be a tau into sinc of omega tau by 2. That is the second way of representation. And third way of representation of this signal will be a into tau into sinc of omega times of tau upon 2 times of pi. So there are three most general way in which you can easily define the rectangular function in its corresponding Fourier transform. After that, please practice to apply duality for this. Duality property I clearly taught in Fourier transform. Please have a look into that. After that, it is very important to know how to shift these three signals into time domain and how to bring this rectangular function from time domain to frequency domain. That is the basic property of duality. This I think these things I taught in continuous time Fourier transform properties. Please have a look into that. Okay, fine sir. This is all about a rectangular function. Let us discuss about the another most important signal is triangular function. The next most important thing is triangular. So when we are observing the triangular function, a triangular function can be written as x of t equal to a into triangular of t by tau. This is the representation of a triangular function, but there is a big difference. Here, tau is not the total width of the signal. The total width of the signal will be, in triangular function, the total width of the signal will be 2 times of tau. Remember this. That is very important when we are observing the triangular function. Okay. So when we are defining the triangular function, let me show you how to define this. Take your time axis. After that, this is okay. This is the representation of triangular function. Now here, if you are observing the width of this triangular function, as I told you, this is minus tau and this is plus tau, and the total width of the triangular function will be defined as twice of tau. Whereas the amplitude of the signal, as usual, it is A only. Now, whenever triangular function you are writing in paper, in theory form, you should remember that whatever the things that you are writing now, you will have to multiply it by 2 in order to obtain the total width of the triangular function. This triangular function can also be written in the alternative way, a into 1 minus mod of t by t. That is the alternative way of representing a triangular function. You can also define like this. Okay. So there is the another approach. This is how we are defining it. Here, the denominator one, that is 1 second, sorry, that is tau. This is how we are defining triangular function in the alternative way. So do remember what are the things that I have given. All are very important properties. The next most important signal is sinc function. Of course, from there also questions will be directly framed. Because as I told, rectangular functions and the sinc functions are having direct relation. Triangular also, see, For triangular, 1 second, I will finish this. Then we will start sync. When it is given triangular, just to recollect once, I wrote all these things in Fourier transform already. A into triangular of t by tau. Suppose if I have a function like this, how should I represent its corresponding Fourier transform, sir? The most important property. This is A tau into sinc square of f into tau. This is one way of representing it. The second way of representing this signal is, this is first way. Second way of writing this signal is A tau into sinc square of omega tau by 2. That is second way of writing this signal. And the third one is A tau into sinc square of omega tau into 2 pi. This is how we are defining, but just to see the difference, the normal difference between rectangular function and a triangular function. After that, practice yourself to transform the signal. Okay, how to apply the properties of duality for this. It's very important how to apply duality in Fourier transform. Duality is the property of continuous time Fourier transform. Go there and cross-examine how to apply this duality property clearly. Try to apply it and learn how to convert this function from, if your signal will be in frequency domain, how to convert it into time domain. And if your signal in time domain, how to convert it into equivalent frequency domain. These two properties are very, very, very important properties. Especially when you people are appearing for state government jobs, direct questions will be framed on duality. So it is very important to remember all these things. Otherwise, it will be stuck. Next is sync function. How to define this sync function, sir? When we are talking about sync function, if I have a sync function in time domain itself, sync of t, its equivalent value, sync of t can be written as unnormalized way, it can be written as sin t by t. That is called unnormalized representation, sin t by t. That is one way of defining the sync function. This is also correct. The equivalent value, sir, you should remember. This can also be written as the alternative way, sin of, this is normalized way, pi t by pi t. You can also define like this. These both are very, 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 very important properties, sir. Suppose this is sync t. This is sync of t. It is given that suppose if you are having something with the sync of a times of t is what I am having. If you are having any function like this now, then this function can be rewritten as, I will tell you, sin of, sorry, once again, sin of pi times of a into t. In the denominator, you will have pi times of a into t. This is the representation of a sync function. So it is very important to have a careful attention with this. Okay. Sometimes what they will ask, they will give some other property. Let me show you. For an example, if it is given that you can observe these things while solving itself, you can easily catch it. Anyway, I will also give the another way. In the examination, sin t will be given. What they will do now, sin of x times of t they will give. In the denominator, y into t, it will be given like this. X and y are some arbitrary constant. If your function will be defined like this, how should I represent it? What about its equivalent sync value? Sin of xt divided by yt can be redefined as, just to take that x and y value outside, such that this can be redefined as x and y times of sync of, I am writing it in normalized way, sync of the function xt, you will have to define, that will not change, xt by pi. You can define a signal like this. That is another most important property. So this is normalized way. This is how we are defining. These both are equal to each other. All you have to do is just remembering these properties. That's it. If I will have simply, see the another way is, if you are having simply sin t by t, we know one way of representation we know. The another way of representation is, sometimes what they will do now, they will give simply sync of. So you know this is a normalized way. It can be defined as sync of pi t by t. That things we know. Sometimes they will also be defined as sin of t by pi. This is one of the representation of the signal. That's it. That is all about the representation of a sync function. Anyway, ultimately you should remember these things. Now, I will tell you the another most important core of sync function. Wait. Sir, most of the time the sync properties you will be applying in Fourier transform, as I already told you. There you will be playing in frequency domain. You will be writing sync of f into tau. This is how you will be defining the function. So there, this function can be written as, how will you write down, sir? Sine of f into tau, and the denominator this will become f into tau. You will have to define like this, no? In frequency domain. If it is given that sync of omega tau by 2, then this can be rewritten as sine of omega tau by 2 upon, in the denominator also you should consider omega tau by 2. Sometimes it will also be given sync of omega tau by 2 pi. Then its equivalent value is going to be sine of omega tau by 2 pi, and in the denominator you will have omega tau by 2 pi. That's it, sir. This is how we are defining this function. So anyway, ultimately you should remember all these properties. Let me define some of the most important integral properties of a sync function. See, if you are integrating a sync function from the interval of minus infinity to plus infinity, it is given that we are integrating the value of a sync function directly. Sync of t with respect to dt. If you are doing like that, no, this net value will be equal to 1. Directly we can say this net value will be approaching to 1. And if it is, this can be redefined now. How I can redefine this function is, we know sync of t is an even function. Sync of t is an even function. This can be defined as sync of t is an, simply we can say this function is approaching to, this function is defined as an even function. So while solving this problem, you can also rewrite this 2 times of 0 to infinity into sync of t into dt. This is also correct. As we are seeing, sync of minus infinity to plus infinity, sync of t into dt will be equal to 1. Now what they will do, no? They will test your knowledge. They will be defining it from minus infinity to plus infinity. They will be taking sync of, they will introduce some arbitrary constant a into t into dt. Then what will be the answer? We know from minus infinity to plus infinity, sync of t into dt value will become equal to 1. If it has been scaled by a factor of a, then your answer will be divided by a factor of a. Your answer will be divided by the factor of a. That's it, sir. It's very simple. If I am having sync square instead of having sync, for triangular functions, you will be getting sync square only. If it is given, suppose if you are running from minus infinity to plus infinity, and it is given that they are taking sync square function, sync square of t into dt. Still it is 1 only. There will be no changes in your answer. Still it is 1. Integral of minus infinity to plus infinity, sync square of t into dt also will be equal to 1 only, sir. Suppose if it is redefined as from minus infinity to plus infinity, if we are having sync square of a times of t with respect to dt, then what will be our final answer? If it is squared and it is also scaled by a factor of a, absolutely your answer will become once again 1 by k only. So it is similar to sync function. So there will be no any big difference between the above sync and the sync square. You will be having same answer only at all cases. Understand, sir? Hope you all understand what I was concluding here. Now, the next signal, what they will do, that is called a sampling function. Hope I am crossing your time. It is our session will be scheduled till 8 only. So rest of things, there are so many things to discuss here. Next we are going to discuss about the properties of sampling functions, then signal functions, then in discrete time signals representations, and in discrete domain how to define the properties of all these signals, properties of even signal, odd signal, power energy calculations. Then we will discuss about classification of system. Okay, so this is all for this lecture. Rest of things we will discuss in the next class.